I'm Benoît. I work at Cash App, and today I'm not talking about Cash App but Wire, which is a library that Square released many years ago to manage your Protobuf schema files, whatever you can think of, generated. And for those who don't know, in case, so proto files are just simple files which defines kind of the API that everybody's going to work on, which is a list of types, can be message, services, enums. And so the nice thing of it is that it becomes the source of truth for all counterparts, so servers, clients, to know how to model types, what the response request would be like. You could even only have messages without services. So even at Cash App we have kind of REST APIs, but the data isn't JSON blocks, it's just Protobuf that we pass on, and so they get serialized as bytes, which makes it efficient, although logging can be a problem. And so the agenda for today, I'm going to talk about Proto 3, which has been released a few time ago, but so Wire had added support maybe a year and a half ago. We'll talk about options. Then the most interesting part for me would be the Gradle plugin to really talk how Wire work in details. And at last I will talk about how we at Cash App manage Protobuf among all services. So Proto 3 was released a long time ago as well. Wire caught up in 2020. And so the big thing about Proto 3 is the concept of identity if absent. Like everybody was like, so in Proto 2 you had for unique fields, you had to assign a label which was either required or optional. And Proto 3 just got rid of it, and like everybody was like, oh, everything is optional, that's great, blah, 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 but it's actually not. And we'll see why. So the identity if absent means if a value is not set, we'll get its default value, which we called identity. Nothing fancy. The only thing that is kind of important is for enums. So when you list constant, the first has to be a 0. Otherwise, you won't be able to compile even with the whatever tool you use. And I'm sorry, as a reminder, so Wire exists. Protobuf is owned by Google, and their own tool to compile Proto, generate it, is called Proto C. So if I talk about Proto C, that means what Google does, basically. And so why everything is not optional? Because it's so not optional that people complain, and they added the optional support to Proto 3. So now in Proto 3 you can do those two. And the difference will be clearer looking at the generated code. In Proto 2, required would be required, you have to pass a value. Optional, it can be null. For Proto 3, no label means it's up, like you don't have to pass a value, but there is a default value. And optional is null. Proto 3 also came with a lot of new types, which was exciting. So everything is under the Google Protobuf namespace. You have any which is generic placeholder. It would be more or less like all your APIs take the object type or the any type, and you just cast, uncast everything. Instead, in this case, we wrap and unwrap. We have duration and timestamp, which are more or less what we have in Java time. Struct has been created to represent JSON objects, so it's just a big map with values. Wrappers are for primitive, numbers, string, just to be able to wrap them, because if you recall, before there was optional in Proto 3, there was no way to have a null value for them, so they had to create wrappers. And the empty is, like for services, everything needs a request and a response type. But if it contains nothing, instead of having to write your own type every time, you can just pass empty. And one big difference between Wire and Proto C is like Proto C would create POJOs for them. It would not try to optimize, add specific logic. So the duration would have a second field, nanos field, this kind of things. And Wire really tried to make the smart trade-off. So we will see about this. This is an example about any. Let's say you have a request, and in some cases, Bitcoin data is filled, in some cases, stock data, and the server would say, okay, depending on what we get, we'll change the logic. Any allows you to have only one field, and basically just set an object into this wrapper, and so the server would be, okay, I try to unwrap this as a Bitcoin data. If it succeeds, this is it, otherwise continues. The positive side of this is if later we add a third type or something else, this request type doesn't need to be updated. And moreover, this piece of code can live somewhere where it doesn't know about Bitcoin or stock data. Like we can really do some kind of a Protobuf dependency injection kind of thing. So good to know. And so this is the trade-off that Wire took for those types. So any was a bit peculiar because you need to wrap and unwrap things. So we create our own native type. But otherwise, when you generate Kotlin or Java, we use the JVM types directly. So if you have a Protobuf duration, when on generation, we add a Java time duration. And same for the other ones. And we'll see how it makes our life easier. As an example, we have a response with a timestamp field, which basically we expect clients to check if the response is still valid, and if not, it's going to fetch again. Kotlin code, nothing fancy. If it's stale, and so because we work on the JVM, we expect to pass time around as instant. With Protoseed, it will look like this. So for the beginning anyway, we create some millis, we pass it, and so Protoseed would create some builders for everything. And so now we need to pass a timestamp to valid until, and so the timestamp object created by Protoseed is itself just a POJO, so you need to do the conversion that you need to do. So let's say server send it, you don't need to do that yourself. And then when you read the value and pass it to some API that expect an instant, you have to extract everything every time and convert it to instant. And although you can create your own helper method or extension function, that's not nice. Because Wire on generation will replace all those with the Java time type, there are no conversion to do. To create an instant from millis, you can use the instant APIs. When you read it, you just need to pass it. And we really like the trade-off we took. We need to talk about JSON because in Proto 2, there was no specification around JSON serialization, which means that even things could work, but there was no contract. There was no guarantee that things would work, and so it would be dangerous to talk between different versions or even between Proto C and Wire. And Proto 3 came with a spec, so Wire is up to spec, so now you can do whatever you want with JSON. No need to worry. And why do we talk about JSON with Protobuf is, in our case anyway, even though all the network calls are using the bytes, notifications are sent with JSON payloads, and even though the server has a Proto schema and knows the type of the notification, clients as well, everything is sent as JSON, so this is something we use as well. Okay, so maybe you all use Proto 3, I don't know, but we have a really big Proto 2 code base, and we see those Proto 3 types, and we're like, okay, we want to use them, but we don't want to migrate everything, we cannot. But what's really nice is you can use Proto 3 types into Proto 2 files. So if you have a Proto2 message request and you want to use the Protobuf duration or timestamp, whatever, you can. Just need to import the Google Proto file, and it works. The only exception is because of the enums identity if absent thing. Proto2 enums didn't require a 0 value. It didn't require this value to be the first. So that's the only thing you cannot do. Use Proto2 enums in Proto3 messages. Otherwise, you can mix anything anyhow. So like a bit like when we migrated to Kotlin from Java, we can do it bit by bit. Same with Proto 2 and 3. Options. So in Protobuf, options are the thing that we see on the right. If you see parentheses, that means they are custom options. Otherwise, it's provided by default by Google. And so a few things to know about options is first, they are just payload. There are no logic bound with it. So whatever you decide to set, either Proto or Wire, nothing's going to happen. There are a few exceptions as usual. The one that Wire will act upon, deprecated, we would add like the deprecated annotation. JSON name would be when you do JSON serialization, we would use this name instead of the field name. Java package, Wire package. Wire package is an option that we added for you in the same repo to generate both with Proto and Wire. And Wire will take Wire package first. If there are no Wire package, we look at the Java package, and if there are none, we look at the Proto package. And so you can generate from the same Proto file, let's say twice Java code from the same type. It's just the package will be different, so they'll be able to live alongside each other. And you're like, mate, I have my option. Like, what am I going to do? So this is an example of an option, which are, so you extend the message options for message options. You have enum options, enum constant options, fields, like anything you can think about. There is a type that you need to extend and say and set. Okay, this is the option I'm going to create. By the way, if you want to make something public, you need to register the value, like the tag of your option to Google somewhere. I forgot the thing, but anyway, when you apply the option, we have our message octagon, and we use the option documentation URL and pass a value to it. Wire added two options to deal with this. The first, emit declared options. If it's true, it will create annotations for the options that you created. And the emit applied will actually use this annotation and apply it on the generated code. And this is how it would look like. Above the annotation we created, and below the type octagon to which we applied the annotation of the option and its value. So then, even if there are no logic bound to it, at the code site you can use reflection, read the annotations, and then do things. So the Wire Gradle plugin, which is more or less how Wire works. So first we have a list of Proto files. And the first step that we do is we pass all of them. And so we have in memory, what we call elements, just a representation of all those files. There are no, it's just a dump passing step. Then we link it, which is like Wire is going to say, okay, we have this type. It says it refers to this type. Let's try to find it. It will just try to resolve all types, making sure the import statements are right, that everything can be found, and that we can actually build something, that can actually build. Then we have a pruning step, which is more or less getting rid of the types you don't want. And at the end, so we generate. Right now we support those 4, Java, Kotlin, Proto, and Swift. And we'll see how to configure each step. So for parsing, you need to tell Wire, this is where my Proto lives. there are 4 ways to pass it. You can pass a directory, a local jar, a remote jar, and you can also now pass modules in the same project. You see that there is source path and proto path. We'll talk about the difference in a few slides. And if you have a list of protos, but you don't want to for Wire to load all of them, you can use the include statement. So saying, okay, just look at those. And so if you had 4 protos, but only 2 include, only those included will be loaded by Wire. And the other 2 would be like non-existing. The leaking step is so when we try to resolve everything, and so if pizza delivery refers types, we're going to try to load those types recursively. And if it refers to a type that Wire cannot find, but you need to pass it without wanting Wire to generate it at the end, this is what protopath is for. And as a good example, so at the top we have the proto source, some pizza stuff, and in the middle, so when we try to resolve everything, you can see that we have 2 types, price and address, which are nowhere to be found. And so Wire will complain, we cannot find them something. And if you pass those as protopath, then Wire in the schema will be able to resolve and load them all. But because they were passed via the protopath configuration, on generation they are omitted. And this is the mechanism that we use when services depend on others without wanting to generate everything every time. So the pruning you can do, so by default we generate everything, but you can prune in 2 ways. First, root, saying, okay, I'm going to mark this type, and you're basically telling Wire to start from a type and look at all its fields and recursively load all types of all fields. And what has not been traversed is just thrown away. So in our case, the type store has been marked as root. And so Wire will just look at root. Okay, so string is a primitive. Looks at address. I'm going to load address, and then recursively each field. Okay, there is country. I'm going to load country. But pizza delivery, even though it was like the top type of the schema, gone, and everything that pizza delivery was referring to, gone as well. The other way to prune is basically saying, okay, those types, I want them gone. It's not ignoring, it's just removing everything. So the same example, if we pruned store and country, you can see in pizza delivery the field store has been removed as well. So on generation, there won't be any store fields. And same for address with the country, but it's product path, so it doesn't really matter. And the last step is generation. So the way to do it, so in Gradle you would pass a block, so Kotlin, Java, Proto, Swift, and the common options between those 4 are include, exclude, exclusive, and out. Include, exclude, it's basically telling to this target specifically, okay, I want you to handle those types only. It has nothing to do with pruning, it's just whatever matched the include statement, I want you to generate, and whatever matched the exclude, just don't generate, that's all it is. The exclusive false or true means if it's true, that means that all types that this target handled are not going to be handled by the others, and the out is just basically where the generation will write files. You can have multiple targets at the same time, even 2 Kotlins. Like for instance, we would have on the same service, we will have 1 Kotlin block generating gRPC for with client APIs, another block creating gRPC with server APIs. In our case here, we have 1 Kotlin block saying, okay, everything that matches this package, I want you to generate it. And because it's exclusive, other targets won't be able to do so. And the other block, Java, just gets everything. And you can see in the image at the bottom the difference between the outputs. There is something we're working on, which is coming soon, like really soon, like days, weeks, which we call a schema handler. So we had a few cases internally where someone wanted to upload analytics based on the Proto schema. We had some people wanting to write, markdown files from Proto files. We have a case where we create the program rules as well using a custom schema handler. So basically looking at all the schema and what we are using, we just write into a rules.profile. And the way to use it would be just a custom block, and you would pass the factory name. And so the API is really simple. You need to implement those two. A factory which has to be serializable because Gradle wants to cache it. And then the schema handler with one method. We give you the prune schema and the context. And the context will have everything that you need, hopefully, to do what you want. So you'll have like a file system. If you want to write or read things, there will be like an error collector if you want to report things, logger. We would pass you the include-exclude payload of the block in Gradle. And so this is coming soon, and if you want to do some custom things, you can. Like even just write a Ruby generator, like anything. And so lastly, so Cache App, we have tons of microservices, and we have also iOS and Android. And this is how we managed our Protos. So it doesn't mean this is the way to do it, it's just an example. So let's say we have the money and customer tab that are shared and used by everybody, so they live in kind of a really low-level repo. Then we have some service trades who deal with payment. They depend on the common to refer to customer money. We have another service, and then we have at the end, it can be iOS or client, doesn't really matter. That depends on services, so they can call APIs of each when they need to. And this is how, and because there are no transitive dependencies of Protos, because we use Protopath instead of both services generating money every time, otherwise we'll have conflict in, like if Wire sees the same Proto file from two sources, it will crash, or like throw. And like Kotlin will do the same. If you have the same file on two class paths, you're done. So common would have two files, one money, like an amount currency, and a customer. Nothing like peculiar. The generating code would be, okay, this is where we have our Protos, and please generate Kotlin. You, at the end, for the other services to depend on this, we'll have to publish the Kotlin code, and then the Proto code as the Proto files as well, because we want to. And so the Wire plugin will by default add the generated code into the source set. So you don't have to go into the source set and say, okay, the generated folder, I want you to add it. No need to do so. And for the Proto files, you could do that to make sure that the Proto files as well are part of the published artifact. But Wire has an option, Proto library true. If you set it to true, the build schema that Wire has in memory, we're going to write it again into the generated folder, and it will be part of the published jar that all other services and clients will be consuming. And so we look at one service. We're importing the two common types. We have a request, a response, and we define an RPC. Nothing fancy. And so we expect at the end the client to call the pay RPC. But so the Wire configuration would be like this again. So we need to publish both generated code and the Proto files. But because we were importing money and customer, now Wire will crash saying, okay, I don't know how to resolve those types. And this is where we use Protopath, passing the Maven coordinates. And because now then the generated Kotlin, like Kotlin itself will be, okay, you're referencing the money type. I don't know how to find it. Now we depend on the same artifact, but as an implementation. And then again, we publish a jar. The other service will do the same. And so client will be different, and we'll see why. So first, client, we would not have any proto locally, because anyway, the protos are defined elsewhere. But we will need to generate everything locally, because every type, like we want every generated message to be parcelable. Otherwise, we won't be able to use them in like configuration changes and when we need to restore and save the state. And because we need to generate everything again, we need to this time source path services publish, like expose proto files. And because there are no transitive dependencies, we need also to add the common one. And so locally we'll generate the Kotlin code that we'll be able to consume directly. And because the compilation time is a bit like it was taking minutes because we have so many protos, we decided to extract just this, basically this work into its own repo, and the Android app would just consume this jar as is. Everything is already compiled, so it's really fast. And this is how we manage protos at Cash App. So I'm finished, but if I have 1 minute, I hope I do. There is one tool that a teammate built that I really like, so I wanted to share about this. It's Protogram. So this is a tool, you pass it bytes, and it will unparse it for you. Because as you remember, because it's bytes, logging is pretty hard to do. So you have the CLI tool, you have a web tool, you can upload files directly or just pass the bytes. You can even upload proto files itself, so it will be able to add the field name to the tags, which is super handy. And what's also really cool is this is on top of Wire, and web is running on JavaScript, and CLI is running on native, which, anyway, a part of Wire is multi-platform, so we are really excited about this. And that's it. I will not take questions with a mic, but if you are interested in anything, please come to me afterwards, and I thank you for coming.